All right, here's that reading as promised. Law of superposition, review reading. The relative ages of rocks. To us, a year seems like a very long period of time. Even a few minutes can seem like a long time when you are waiting for food to cook or paint to dry. The Earth has been around for a very long time. Such a huge amount of time that it's hard to even imagine. Scientists date the Earth at 4.6 billion years old. We call the Earth's history geologic time. Humans like us are relatively new to in the geologic time. Modern humans have only been around for about 300,000 years. For a long time, scientists wondered what life was like on Earth before humans were there to take records. They also wanted to know when the first life forms were found on Earth and what the oceans, continents, and atmosphere were like at different points in geologic time. One way that scientists can learn about the past on Earth is by studying fossils. Fossils are preserved remains of once living organisms. There are fossils of animals, like dinosaurs, but also insects, plants, and even bacteria. Fossils can be molds of living things in rock, insects trapped in amber, footprints or nests, or many other kinds of remains. A person that studies fossils is called a paleontologist. So, how do paleontologists know how old fossils are? How do they know which animal came first when looking at two fossils? Scientists can use radiometric dating to determine the absolute age of a rock, how much time has passed since the rock formed. This method relies on naturally radioactive elements in rocks which decay over time. However, without taking a fossil to a lab, you can quickly determine which rocks and fossils are the oldest and youngest just by looking at the layers of rock. This is called relative age. Relative age is the age of a rock or fossil compared to the rocks around it. When we find relative age, we can say that a rock or fossil is younger or older than another, and we can estimate the age. Scientists usually use a mixture of both relative age principles, like the law of superposition, and radiometric dating in order to learn about what life was like on Earth millions or billions of years ago. How can we find the relative age of a rock layer or fossil? Imagine you are stacking a cake with four layers. What layer do you stack first? The bottom one, right? If you try to stack the top layer first, it will fall through the air and land at the bottom. Strata, or rock layers, are exactly like the layers of a cake. Sediments are pieces of rock and they pile up in layers on the ground. Over time, and as they are buried more deeply, they are compacted into layers of rock. The law of superposition states that the oldest rock layers are at the bottom of the pile, and the newest or youngest rock layers are at the top of the pile. The same is true for the fossils found in the rock layers. The fossils at the bottom of strata are older than the fossils found on top. There are a few other things to keep in mind as you look at strata and try to determine the relative ages of fossils or rocks. Fossils are usually found in layers of sedimentary rock. Sometimes magma will come up to the surface through layers of rock or strata. We call this an igneous intrusion. Igneous means a rock cooled from magma or lava, and intrusion means it happens underground, inside the earth. When you see an igneous intrusion, you know that it's younger than the rock layers it cuts through, even if it's close to the bottom. Think about it. The rock had to exist before the intrusion could come along and break in. Sometimes lava will flow from a volcano on the surface of the earth. We call this an igneous extrusion, exiting the earth on the surface. Extrusions are easier to date since they happen on the surface. The law of superposition usually still applies. Sometimes rock layers can be cracked by earthquakes. We call a crack or break in the Earth's crust a fault. All right, last one. The fault is younger than the rock layers it cuts through. The fault is just a crack, so the rock had to exist before it could get cracked. Sometimes scientists will have an unconformity in the fossil record. An unconformity is where a layer of rock is missing due to erosion or worn away rock. So, last but not least, we have index fossils. Index fossils are one way that scientists can find the relative age of a rock layer. Index fossils are the preserved remains of organisms that follow three rules. Number one, they lived around the world or had a large habitat. They are easy to recognize, and they lived for a relatively short period of time before they went extinct. Their species completely died out. Scientists can use index fossils as markers of specific time periods. For example, the trilobite is an index fossil. Trilobites were like prehistoric horseshoe crabs, and they filled the Earth's ocean for a few 100 million years. If you find a trilobite fossil, then you know the age of the rock layer it was found in. Index fossils act like the markers of known points in geologic time. All right, thank you for listening. Now let's answer some questions. Thank you.